Okay, so continuing Unit 3 with light equations. You need to make sure while you're taking these notes that you have your light equations guide out. Let's begin. Okay, so recall from class today that this is your light equations guide. You've got your 3 formulas here, and you've got the 2 constants that you need, the speed of light and Planck's constant. You also have a box that tells you all of the units for each variable in these equations. And then in our problem today, we're going to be using the visible spectrum of light. Basically, it tells you what color the light will be based on its wavelength. So let's work on an example problem. We're going to be using the entire map, is what I call it, up here. We're going to use all 3 formulas for just one problem. So let's dig in. Okay, so there's one question we're going to be answering during this video, and it's how do we use light equations to solve problems? So here's an example of a very difficult problem where you're going to have to use all 3 formulas. So while doing an experiment with volatile materials in a chemistry lab, your apparatus blows up with a bright flash of light. There just happened to be a photometer turned on in the lab, and it registered total light energy of 1.19 times 10 to the negative 14 joules. So they just gave us the total energy, and it also says the total number of photons was 30,000. So they also gave us the number of photons. They gave us 2 things, and there are 3 parts. First thing they want us to find is the frequency. So we need to look for V, the frequency. And then the next part, it says we want what was the wavelength of light. So we want to find lambda, the wavelength. And then it says what color of light. So based on the wavelength, we're going to also answer what color that is. So let's just start working out part A. Okay, so from that problem, we were given total energy and we were given the number of photons. We want to find the frequency, the wavelength, and the color of light. So when you're looking at this, treat this like it's a map. We are starting over here, and we want to work our way over to frequency, wavelength, and the color of light. So in order to get there, you're going to have to pass through one very important thing. We need to find the energy of one photon so that we can move on and progress our way through the map. So the first thing that we need to do is use this formula here, because we have the total energy and we have the number of photons. So now we can find the energy of one photon. So let's plug in our numbers and do the math. Okay, so we're first going to use the total energy formula. They gave us the total energy in the problem, so we're just going to plug that down in our equation. So 1.19 times 10 to the negative 14. That equals the energy of one photon, which we don't have yet, and that's what we're trying to look for, times the number of photons, which was also given to us in the problem. So we're going to plug those numbers in. If you notice, in order to get the energy of one photon, we need to get this by itself. So we're going to divide by 30,000 on both sides and plug that into our calculators to get our answer. So the energy of the one photon would equal 3.97 times 10 to the negative 19. And this is energy, so it needs to be in joules. So we just use that one formula by plugging in the numbers from the problem. So now that we have the energy of one photon, we can go down to the next formula. The energy of one photon equals Planck's constant times V. Remember, we're trying to find the frequency. So we're going to plug in that energy of one photon that we just found, 3.97 times 10 to the negative 19. And that equals H times V. We don't know V, but we do know Planck's constant. It's on your light equations guide, 6.63 times 10 to the negative 34. So again, just like the problem above, in order to solve for V, in order to get this by itself, we need to divide by the number that is being multiplied by, 6.63 times 10 to the negative 34. Play fair and do this on both sides. So whenever you type this in your calculator, don't forget that these are scientific notation numbers, so they need to be in using the format of E. So whenever you type that in, you're going to get 5.99 times 10 to the 14th. And since this is frequency, the unit is going to be in hertz. So we just used two formulas on your light equation guide to find the frequency of light. Okay, so the next question wants to know what was the wavelength of light. So we now have V, which equals 5.99 times 10 to the 14th. We have that number, and now we want to look for the wavelength. We want to find lambda. So let's go look at your light equations guide to figure out what it is we need to do. Okay, so far we have found, we were given total energy and number of photons. We found the energy of one photon so that we could finally find the frequency to answer part A. So now in order to find lambda, you have to use the speed of light formula in order to get to lambda, the wavelength. So in order to use that formula, we need the speed of light constant, which is right here, and we need the wavelength, which we have already found from part A. So let's plug those numbers into the formula and do the math. Okay, so we have our formula. The speed of light equals wavelength times frequency. Recall from part A, we already found the frequency. It's 5.99 times 10 to the 14th. And so now let's plug in our numbers. So from your light equations guide, we see that the speed of light is 3 times 10 to the 17th. That equals the wavelength, which we don't know, times the frequency we found from part A. So when you plug in your numbers, you see that in order to find the wavelength, we need to move the frequency over to the other side. So it's being multiplied. So in order to get rid of it and move it over, we're going to divide. Divide on both sides to play fair. So in your calculators, you would type in the speed of light divided by the frequency, and you're going to end up with a number that is not in scientific notation. Wavelength is usually in around the 400s, 500s, or 600s. So we got 500.8, and wavelength always needs to be in nanometers. So using the speed of light formula, we were able to find the wavelength. Okay, so the last and final part, it wants to know what color of light did you see. Now, if you look at your light equations guide, in order to know the color, you need to know the wavelength. You need to have that number, and we actually found that already in part B. So what you need to do is look at your light equations guide and see what range this wavelength falls in, and that'll tell you what color. So let's go look at your light equations guide. Okay, so if we look, our wavelength is 500.8. So if you look at the box on the bottom of your light equations guide, you need to see what range 500.8 falls in. So if you look right here, we have 490 to 574. Those are the wavelength range for green light. So our wavelength falls in this range right here. So that means our light is in the color of green. Okay, so based on our wavelength, then that means our color is going to be green because it falls in the green wavelength range. Okay, so just to summarize the video, you don't need to write a summary for these notes, but I do want you to recognize what it is you just accomplished. So in the problem, it gave you the total energy and the number of photons. It wanted you to find frequency, wavelength, and the color. So what we had to do in order to find that is we first had to find the energy of one photon using this first formula here. Based on that, we were able to plug that into the next formula to find the frequency. And then from there on, we were able to plug the frequency into the final formula to find the wavelength. And then based on the wavelength, we were able to determine the color. So this is how you can use all three formulas just to solve one problem and find everything on the light equations guide.